As efforts toward carbon neutrality advance worldwide, renewable energy is expected to be adopted more widely in the future. However, the generation of renewable energy from sources such as solar and wind power fluctuates widely depending on weather conditions. Because of this, depending on the area and time of day, some ICT sites, such as data centers, cannot fully use up the energy generated from renewable sources, while sites in areas with unfavorable weather suffer from a shortage of power. To solve this problem, NTT Network Service Systems Laboratories has developed renewable energy-aware virtual network control technology. This technology uses virtualization to move workloads from sites expected to have insufficient power to sites with surplus power, based on forecasts of renewable energy generation and power consumption, and also takes communication quality into consideration. Let's look at how this technology works. There are 4 sites, 2 each in eastern and western Japan. First, the system obtains forecasts of the amount of renewable energy generated and the power consumption at each site, and calculates how much surplus power will be generated at each site. Next, the system collects information about power consumption for particular workloads whose processing time frame and site can be reassigned. The parts that have changed color in these charts indicate those workloads whose processing time frame or site can be reassigned. Workloads with the same characteristics, such as service content and user location, are grouped together to improve the efficiency of the workload allocation calculation. The grouped workloads are allocated to sites within specific time frames, taking into account where and in what quantities surplus renewable energy is being generated. Workloads are allocated using the workload allocation method, which was developed by the laboratories. In order to use surplus power as effectively as possible, this method combines workloads with different service requirements and efficiently derives workload allocation scheduling with due attention to quality of service. Let's look at how this technology is used. Early in the morning, no renewable energy is being generated and no surplus power exists anywhere. Later in the morning, surplus power is expected to be generated in western Japan, where weather conditions will be good. Therefore, during the period when surplus power is generated in that region, workloads in eastern Japan are moved to western Japan. In the afternoon, weather conditions in western Japan are expected to deteriorate, resulting in a shortage of power. Eastern Japan will have sunny skies and will have surplus power. During this period, the workloads will be moved from western Japan to eastern Japan. By moving workloads from site to site, it is possible to improve renewable energy usage and help to achieve carbon neutrality.